Okay, for this lesson, we're going to learn about the principle of moments and how to balance an object. These are the learner's outcome. These are some prior knowledge. Okay, equilibrium. When an object is subjected to equal and opposite force, when you add up all the forces, it has a net force of 0. So what we mean is that if your object, you have equal and opposite force, it has a net force of 0. And this is what we know as equilibrium. So if you have up and down, okay, so if they are equal, you have equilibrium or net force of 0. This is known as translational equilibrium. Okay, we are going to talk about rotational equilibrium, and it's similar to translational equilibrium except that it's not only about forces. Okay, if you have an object that's at equal and opposite moments or turning moments, or for example, if you have a anti-clockwise moment that causes to turn this, and you have also a clockwise moment that causes it to turn it clockwise, you find that if they are equal and opposite, the total turning moment is 0, and what it means is that it has rotational equilibrium, means that the object would not rotate and would remain in balance. So principle of moment states that when an object is in rotational equilibrium, the sum of the anti-clockwise moments about a turning point must be equal to the sum of the anti-clockwise moments. And turning point means simply means it's the pivot. But take note that rotational equilibrium is the sum of the opposing moments are equal, and it's not the force. Okay, and turning moment is actually force times perpendicular distance. So for an object to be in balance or not to rotate, the opposing forces magnitude can be different as long as the total opposing moments created by the forces are the same. So this is a simple example. You have this object and then there are two forces, one is up and one is down. So, and with O as the pivot. So it could be 5 Newton up and 10 Newton downwards. You realize that the forces are different, okay? But this 5 Newton will create a anti-clockwise moment, okay, and it is applied 3 meters away from the pivot. So it's 5 times 3, 15 Newton meter. And this 10 Newton will create a clockwise moment because it causes the object to rotate this way. And if the distance is just only 1.5, similarly it is multiplied by 1.5, it will be 15 Newton meter. So this one creates a anti-clockwise, this one creates a clockwise. You find that even though the forces up and down is different, 5 and 10, the turning moments created are actually equal, and in this case the object will be balanced and would not rotate. Of course, just now was a very simple situation. So right now you have this one that's more complicated, where you have a variety of forces at different locations. So based on this information, how do we actually understand that the object is balanced or unbalanced? So if you want to determine balance or unbalance, just apply the following steps. So step 1. First, determine the location of the pivot. So in this case, the pivot is over here, and you can label as at O. Step 2, determine all the forces on the object. So you have this force 4, 3, 1, 6, 10 Newton. Okay, so this 5 Newton. But ignore the forces that are on the pivot. Okay, for the forces, just take note that it's where, location of the force, and the magnitude of the force. Okay, what do you mean by ignore the forces that are on the pivot? Okay, you find that actually there is a force that is on the pivot that's supporting upwards. Okay, because in order for this object to be stay in balance, you find that the total upward force and the total downward force must be equal. So in this case, total downward force is 16, 10, 1, 5. So this one actually there's also additional 6 Newton. But if the force is on the pivot itself, you actually ignore it. Okay, so right now create a sort of like this table that has anti-clockwise and clockwise separated, and force, the distance, and its turning moment. So the next step is to categorize the direction of the moments created by the force and categorize them according to anticlockwise or clockwise. So how do we determine it? So if this were to be the pivot, you find that a 4 Newton would cause this object to turn it in this manner. So 4 Newton would be anticlockwise. Okay, you find that it will turn it this way. So for 5 Newton, you find that it will cause the object to turn it this way. So in this case, this direction is the clockwise. 1 Newton, similarly, will also be clockwise. So we classify under clockwise. Okay. So right now, 6 Newton, okay, you have to be careful. Because even though it's going upwards, same as 4 Newton, but because it is the pivot is this side and this is 6 Newton, you cause the object to turn this way. So 6 Newton is actually under clockwise. Okay, it's actually the same. It's actually the same as the 1 Newton and 5 Newton. So 6 Newton is actually clockwise. And similarly, 10 Newton is causing the spin this way. Okay, it is under the anticlockwise. So you need to be able to classify based on where the pivot is, classify whether the forces is anticlockwise or clockwise. So then next, determine the perpendicular distance for each of the forces to the pivot. So this is just only an example. So we start from the pivot. Okay, for example, 4 Newton is 4.5. So we just fill it in. And then 5 Newton is 3. Put it in. 1 Newton is 1.5. Put it in. 6 Newton is 1.5. Put it in. And 10 Newton is 2.5. Okay, put it in. Next, step 5 determines the moments for each of the forces. So remember, the moment is force times the perpendicular distance of that force to the pivot. So this is very specific. 4.5 multiplied by 4, which is 18 Newton meter. And 5 times 3, 15. And you just do accordingly. And just add up all the moments for anti-clockwise and clockwise separately. So just add this up, which is 43. And you add all this up, will be 25.5. So the last step is to determine whether does it balance or unbalance by comparing the total anti-clockwise moment with the clockwise moment. So it's very simple. Anti-clockwise more than clockwise, which means that the object would rotate anti-clockwise. So in this case, actually 43 is bigger than 25.5, so the entire object would actually spin in the anti-clockwise manner. Okay. But however, if let's say this anti-clockwise is smaller than clockwise, it means that the object would rotate clockwise. Right. And if, of course, the last case is that if both of them are equal, then the object will not rotate or will remain balanced. So this is a summary. Determine location of pivot, determine the force, and categorize the force into anti-clockwise and clockwise. Determine the perpendicular distance of the force to the pivot. Determine the moments. Then add up all the anti-clockwise and clockwise separately and compare them. And these are 3 cases that is possible. Do take note that the object will only be in balance if and only if its anti-clockwise moments equals exactly to the clockwise moments. So a balanced object will become unbalanced if you change either of the magnitude of any of the forces, or you change any of the perpendicular distance of the forces. So that's why with it is quite easy to upset the balance of an object, because you change anything, you will just unbalance. Or you could also be thinking of it's difficult to balance an object on a single pivot, since you need to ensure that anti-clockwise moment is exactly equal to clockwise moment. Okay, so that's all for this lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.